Reid. Thank you so much. So, as you indicated how Shima and I are going to be sharing this presentation, I will start out, she will take over, and then I will finish up. You can see the graphics on the first slide. The darker the dots, the less affordable transportation is. And in Portland, you've got very light dots right in the center, downtown and in the inner ring suburbs. And then at the very periphery, you see darker dots. The darkest dots in this case are brown. And so there isn't any publicly or rental assistance project, publicly subsidized rental assistance housing in Portland that is at its most expensive. In Phoenix, you don't have any of the light dots, and you have very few of the kind of orangey dots. It's mostly brown, and in the far outside suburbs, you actually see some very, very dark brown dots, which are the most expensive. So that's what we're looking at. We're going to be talking about the methodology we use to generate these graphics and the implications for housing plus transportation affordability. And that's what we've done. We thought that that the way to look at housing affordability is in fact in terms of both housing and transportation. This isn't a new idea, but we're taking an idea that the Center for Neighborhood Technology in Chicago originated and using it, applying it to rental assistance properties of HUD to see just how affordable they are when you include transportation as well as housing in the mix. Okay, so total housing costs at or below 30% of gross annual income is, according to HUD, affordable. It's a definition of affordability. It's been used nationally, it's been used internationally. It's also a legislative standard to qualify applicants for housing assistance. HUD rental assistance recipients are to pay no less than 30% of their income and no more than 40% of their income on housing. But that does not relate to transportation at all, and transportation is an add-on to housing cost. So we can assume, therefore, that housing costs are affordable for households that participate in the HUD rental assistance program. But then how about transportation costs? And the simple idea behind this study is if households are located in remote areas, have to own 2 cars, have to spend a lot of their money on gasoline, even if housing is affordable, the combination of housing and transportation costs may not be. So why worry about transportation? Well, it's the second largest item in the typical household budget. As you can see from this pie chart, housing is on average 33% of the household budget. Transportation is another 17.6%. Food is the third most expensive item in the household budget, but you can see that the combination of housing and transportation amounts to more than half of the total household's budget. And transportation rivals housing in some areas. There are metropolitan areas in the country where transportation is as expensive as housing, and not on average, but there are places where it is, and in those cases the combination of housing and transportation cannot be deemed affordable. So we're seeking to determine whether HUD rental assistance programs provide affordable housing when transportation costs are factored in. We give a nod to the Center for Neighborhood Technology. They were the first to compute H plus T, that's housing plus transportation affordability, in terms of an overall index. And their original work, which dates back quite a while, over about around a decade, I believe, maybe a little more than a decade, has been superseded by their own work on what's called the Location Affordability Index. It's the same idea. It's housing plus transportation, but better models. Their newer models are better. My understanding is that HUD spent a lot of money. I've heard $3 million developing the Location Affordability Index, and it is an improvement over the original H plus T Affordability Index. We're trying to improve on the Location Affordability Index in our NITC funded study, and we want to acknowledge NITC for having funded the work that we're describing today. So the H plus T index considers a whole lot of variables. That whole list on the left-hand side of the slide. It is part of the affordability calculation, considers household characteristics like median household income and household size. It also considers neighborhood characteristics like gross density and regional household intensity, which I assume is a measure, again, of density of households. It considers transit availability, connectivity index to transit. This is all in the original H plus T index. As you can see from the arrow, these variables, neighborhood characteristics and household characteristics, together determine auto ownership, auto usage in terms of vehicle miles traveled, and public transit usage. These are three components of transportation costs. If you own more automobiles, your transportation costs are higher. If you have to use your automobile more and generate more VMT, transportation costs are higher. If you are using transit for some of your trips, transportation costs are higher. The three of them together create an estimate of total transportation costs, and that can either be less than 15% or more than 15%. That's the definition of affordability. Less than 15% transportation, according to CNT, that's Center for Neighborhood Technology, transportation is affordable. More than 15% not affordable. And we in fact have looked at ranges of transportation costs to say very affordable, affordable, not affordable, and very unaffordable. Those are the categories. Now, the original CNT H plus T index has been superseded in the work funded by HUD. This is a map of Salt Lake City, and what you see is for this particular section of Salt Lake City, housing is 27% of the household budget. Transportation is 19%, and the combination is 46% of the household budget. If you buy the idea that transportation should be 15% or less, housing should be 30% or less, the combination of the two is more than 45%, and hence at this particular location, housing plus transportation cost is marginally unaffordable. It's more than 45%. The sum of the two is from the Location Affordability Index. The typical household owns 1.9 vehicles. That's a lot of expense associated with the fixed cost of auto ownership. According to H plus the Location Affordability Index, the typical household would drive 21,280 miles annually. That means a lot of gasoline consumption and high cost associated with it, and the typical household would own or would make 104 transit trips, which also adds to the cost of transportation. This is from the Location Affordability Index of the Center for Neighborhood Technology as implemented in HUD's Location Affordability Index. So just slightly above the 45% standard for affordability. There are certain shortcomings, and we're not taking anything away from CNT or HUD, and they were groundbreaking in adding transportation to housing to figure out what constitutes affordable housing, but there are limitations or shortcomings. One is limited characterization of the built environment, and I'll be talking more about this in just a second, but we now and have since about 1997, when Cervero and Kockelman came up with the whole idea of D variables, the D's being density, diversity, land use diversity, street network design, destination accessibility, and distance to transit as the 5 D's. We consider all of the D's, and LAI does not. The LAI index relies on VMT is estimated in a model to rely on VMT from only one state, Illinois. There's an issue when you're relying on only data from Chicago and St. Louis. There's an issue referred to by researchers as external validity, and we look at data from more regions to increase the external validity of our models. Some of the models are based on aggregate data. Researchers for decades now, from the time I was in school, and that's a long time ago, have preferred to use disaggregate data. There's a problem with using aggregate data at the block group or census tract level. It's called aggregation bias, and so models are considered to be more valid and reliable if they rely on disaggregate or household level data. The LAI, the Location Affordability Index, uses national level unit cost data, so it's the number of miles that someone is driving is multiplied by a cost per mile, which is a national cost figure, and we, by contrast, look at region-specific data. Models are for typical households, not low-income households. The LAI considers all households. We consider only low-income households, the ones that would be eligible for HUD rental assistance. This is ours again, disaggregate data, accounting for all the so-called D variables and being specific to low-income households. These are the innovations that we made with the funding from NITC, National Institute of Transportation and Communities. Our data come from 15 regions at this point. We're increasing to more regions, but 15 regions, and the 15 regions, as I mentioned before, that gives us the quality of external validity. The regions are as diverse as Boston versus Atlanta, Portland versus Houston. The fact that the regions vary so dramatically in their built form, in the amount of transit that's provided, Boston with a heavy rail system, Salt Lake City with light rail, Eugene with bus rapid transit, also increases external validity. So the 15 regions that are part of our study were selected for of data availability. The household travel surveys we got from the 15 regions had to provide us with XY coordinates. We wanted to be able to zoom in on the built environment within easy travel sheds of people's homes. And we needed to know exactly where the households were located. XY coordinates are latitude and longitude coordinates, so we know precisely down to the address level where the households live. We know in terms of trip ends where the trips start and where they end precisely, so we can compute the distance of the trips. The land use databases that we use in this particular study, we needed parcel level detailed land use data. We wanted to know, within that buffer zone around households, whether each parcel was commercial or residential or institutional. And we needed parcel level data to answer those questions and to compute the D variables, the density, diversity, design variables. We needed parcel level data. Here's our sample. We've been working on this for over 5 years, compiling the data from the different regions. You can see the dates of the surveys. The oldest one, as I recall, dates back to 2000, that's Sacramento. Most of them are much more recent. There are 62,000 households in our database, many fewer low-income households, low and moderate income, but 62,000 regions and over 600,000 trips. So we have a very extensive database on which to base our models. We also, since we know precisely the location of the households, we can look at buffers, street network buffers around each household. You see there a quarter mile right around the household is shown with a red dot. Right around the household, a quarter mile, half mile, and 1 mile buffers. For those 3 buffer distances, we computed D variables. So we know the activity density within a quarter mile, the activity density within a half mile, the activity density within 1 mile. That's the blue outside buffer. And since we don't know which buffer has the most effect on household travel, is it a quarter mile, kind of the nominal walking distance? Is it a mile, a short auto trip, or maybe a bicycle trip for the household? We needed to estimate D variables for buffers of different width, and that's in fact what we did for the thousands and thousands of households with low incomes, low and moderate incomes within our sample. The D variables I mentioned before, but they have become rather standard in household travel research. The first D is development density. Second D is land use diversity. Third one, as I mentioned, is street network design. Fourth one is destination accessibility, usually measured in terms of the number of jobs that can be reached within a given travel time. We use 10 minutes, 20 minutes, and 30 minutes to measure destination accessibility to jobs. Distance to transit, we know exactly where all transit stops are located relative to households, and we know how many stops there are within given distance bands. Development scale is another one we've used for, not for this work, but for other work. And then we have the final D, the 7th D, which is demographics, which also affect household travel patterns. People with higher income travel more, own more automobiles, and so on. So for individual households, we have these variables, adding them now. Transit frequencies was added for this study. That's a measure of distance and transit service frequency and quality. Activity density, job population balance, land use mix, intersection density, and proportion of four-way intersections. Those last two being under the heading of design, the D variable design. And we also have whether households live in single-family housing units or multifamily housing units. The dependent variable, the variables we're using to estimate cost, transportation cost, are VMT at the top of the list. They're household transit trips and number of vehicles owned by each household. So these are the ones we need to compute transportation cost. And then we have variables at the metropolitan level. The population of the metropolitan area, basically in larger metropolitan areas, people make longer trips, so that increases VMT. In larger metropolitan areas, there are better transit systems, more complete transit systems, so that increases the number of transit trips while reducing the number of vehicle trips. And then finally, household vehicles, which also vary. Basically, the larger metropolitan areas, because they have more transit and typically better walking environments, they also reduce the number of household vehicles owned by the typical low-income household. So this gives us what is called a nested structure. We have nesting of households within metropolitan areas, and that requires a type of modeling that has not been used much in planning, but has been used for literally decades in education research, in the last decade or more in public health research. It's called multi-level modeling, where the total, whatever the dependent variable is, where that dependent variable, that the variance in that variable, for example, in household vehicle miles traveled, is partitioned between the household level and the regional level, and models are estimated at each level. That's called multi-level modeling. It's state-of-the-art for travel modeling. We also estimated what are called hurdle models, and I don't want to get into this too much, but and if you have questions, we'll try to answer them at the end of it. But hurdle models have not been used much in planning either, but they are state of the art. You have for households some that don't generate any vehicle miles traveled at all. A lot of them that don't make any transit trips. So you have one model, a stage one model, that says what is the probability that a household generates VMT or transit trips. Then in stage two, the model estimates how much VMT and how many transit trips are generated for households with any VMT and transit trips. Some households, again, in stage one, not being predicted to have no VMT and no transit trips, most of them having VMT and most of them not having transit trips. So that's what, as I said, what's called a hurdle model, and that's what we used. And that's technical and not obviously what's of greatest interest, but we wanted to estimate the models correctly. We believe that you need to estimate models the way we did, and the location affordability index does not estimate models as we did. So here's our first model, and I'm going to spend time only on this. I will not go into any detail on the others, but the household vehicle ownership model says that you can see the coefficients in the left column. It says that the more people in the house, that is, the larger the household size, HH size, the more vehicles are owned. The more workers in a household, the more vehicles are owned. The higher the household income, the more vehicles are owned. Those living in single-family houses own more vehicles. Everything else being equal, these are regression models, so everything else has to be held constant, but those living in single-family homes tend to own more vehicles. Now the remaining variables are the D variables, the other D variables, and EMP 10A is the proportion of jobs within the region that can be reached within 10 minutes by automobile. And the more jobs that can be reached within 10 minutes, the lower the vehicle ownership. This finding that job accessibility reduces vehicle ownership dates back to the original LUTRAC study, Land Use, Transportation, Air Quality study in Portland, Oregon. So we've known for a couple decades that households living in highly accessible regions do not need to own as many automobiles. Activity density within a quarter mile is the next D variable. It's ACT-DEN Q mile. This says that the higher the density, activity density is the sum of population plus employment within a quarter mile divided by the area within a quarter mile, and people living in dense areas do not have to and do not own as many vehicles as those living in low density areas. Entropy within a quarter mile is a measure of land use mix. Basically, the more balanced land uses are, the higher the entropy score, and in these mixed use areas within a quarter mile of home, the households don't own as many vehicles. Intersection density within a half mile, that's INT-DEN H mile. The higher the intersection density, the more street connectivity, and the fewer vehicles are owned by households. Just two more. Intersections within the proportion of intersections, four-way intersections, that's INT 4 WH mile. The higher that percentage, the more street connectivity, the fewer vehicles are owned. Basically, households don't have to own as many vehicles to meet their daily needs where they're in a dense, compact grid of streets. And then transit frequency, the T freak, is the last of the variables. Those living in highly served areas served by transit don't need to own as many vehicles. So that's one of our models. All of these variables are statistically significant. All of them have the expected signs, and these are really terrific models for estimating how many vehicles households own to meet their daily needs. And that, of course, determines transportation cost. And VMT, the models have the same sort of variables. They all have the right sign. These are hurdle models, model of log odds of having a household having any VMT, and then for those households that have VMT, the log of household VMT. Same thing with transit trips, same models, same variables, all with the expected signs. Basically in these areas with high intersection density, with entropy, people make more transit trips, and with higher transit frequency, of course, more transit trips. And here's our multifamily portfolio. Each dot represents one of the HUD rental assistance projects. You can see they're all over the country. And I'm going to turn this over to Shima now, who's going to talk about the cost models.
Thank you, Reid. I am going to talk more about the cost models and share with you some of our results. So as you see from these slides, our transportation costs consist of vehicle costs, which is households' expenses to own and use private vehicles, as well as public transit costs, which is basically transit fares. So our vehicle costs are divided into fixed and variable costs. As you see, fixed or ownership costs are not generally affected by the amount of vehicle is driven. Depreciation, insurance, registration fees are examples of fixed cost, while fuel is a variable vehicle cost, is the most important one, which is proportional to mileage. I'm going to talk about each of these cost components in more detail. Let's start with the car ownership or vehicles fixed costs, which is our first component. We were interested to know how much costs for a household to own a car for low-income households. So we went to National Household Travel Survey 2009, and we selected only low-income households based on the HUD's income threshold for being qualified for assistance programs. And for those households, low-income households in the sample, we looked at the most popular vehicles they use and they're reported to use. As you see from the table, Ford F-Series is #1, with which about 4,000 households in NHTS reported that they use this as their main vehicle in the households. So we found top 15 most popular vehicles, and then we went to a website called True Cost to Own, and for each of those 15s we looked at how much it costs to own a car. Now they have different factors in considering in their computation: depreciation, taxes and fees, as you see, financing, fuel, insurance, maintenance, and repairs. We included all factors but fuel, because fuel was a part of variable cost, as I mentioned earlier. So we computed the fixed costs per car for the top 15 for each state. Then we averaged them to find the fixed cost per vehicle. And we multiplied that by the number of vehicles, predicted vehicles we found from our modeling, which Reid just explained, to find the total fixed costs of car ownership. The next component was car use, or basically variable costs. For that, we looked at average gasoline prices from the oil price information systems. We purchased that for all metropolitan areas in the US for 2010. We inflated them to $2014 as we were interested, as you see from the table, that the costs of gasoline varies between metropolitan areas. It's sometimes the variation or the range is up to $1. So we wanted to account for this variation. So we look at the metropolitan area level fuel costs, and we multiply that by predicted VMTs from the modeling exercise that Reid just mentioned to obtain the household's operating or variable vehicle costs. Finally, the third component, or transit costs. For computing that, we obtained transit fare data from the National Transit Database. We computed average transit fare for each region by dividing the total transit revenue by total number of unlinked passenger trips for the region. And we multiplied that by the predicted number of transit trips to obtain the household's public transit costs. Having the three cost components, we added them up together to find the overall transportation costs for each of the properties in our sample. We divided that by income as was defined by, again, the income limitation for HUD's being qualified for HUD's assistance program. And we obtained the percentage of income spent on transportation for each of the properties in our sample. Here is the frequency distribution of transportation affordability, or percentage of income spent for transportation costs, for 18,000 properties in our sample. As you see, we found that on average, a typical low-income household who is qualified for HUD assistance program spends about 15% of its budget on transportation, which basically agrees with LAI recommended 15% threshold for transportation affordability. And we also looked at the map showing the variation of transportation costs for HUD multifamily properties in U.S. metropolitan areas to see if it varies from metropolitan to metropolitan. And as you see, the red color shows unaffordable properties where a typical low-income household spends more than 50% of its budget on transportation. And the orange color represents affordable properties where transportation costs are less than 15% of income for a typical low-income household. As shown in the map across the U.S., as you see, cities with good public transit service, such as Portland, Oregon, have in general lower transportation costs, particularly in downtown areas, while properties in auto-oriented cities, such as Orlando, Florida, as you see, have high transportation costs, even housing units that are located in downtown areas. The results were also at the same line with LAI transportation cost calculated, which shows a typical household in an accessible central location spends significantly less on transportation than the same household in a distant area. But looking at the metropolitan areas with the highest number of unaffordable as well as affordable housing also give us some interesting findings. We found that overall about half, or 48% of all properties in our sample were unaffordable, spend more than 15% of their income on transportation. So if you look at some case studies in more detail, you see that according to the table in front of you, there are metropolitan areas such as Phoenix, such as Houston, and other metropolitan areas in this list. As you see that they have the higher number of unaffordable housing units than you know, a more accessible and more transit-oriented cities, as I mentioned again. It's very interesting to see that these and other metropolitan areas in the table found to be among the most sprawling MSAs in the country by previous studies, including the study has been done by Reid and I in 2014, that we found these areas, Riverside, San Antonio, Tampa, Phoenix, Dallas, and Houston, and so on, to be among the sprawling areas. Also, looking at the list of metropolitan areas with the highest number of affordable housing, you would see cities like San Francisco, Los Angeles, Denver, New York, Portland, and so on, which again, according to our study, are among the the most compact metro areas in the country. Now, this is not to suggest, of course, that the rental assistance programs should be limited to compact metropolitan areas, but rather to suggest that channeling subsidies into accessible neighborhoods is even more important in sprawling metro areas than compact ones. I now turn it to Reid.
You go ahead and finish it up. Go ahead.
Okay. Okay, I'm gonna share with you more results. Well, if you we look at more case studies, you will see, for example, again, what I mentioned about accessible areas, transit-oriented areas versus suburban or ex-urban distant areas far from downtown. Washington, D.C., many of the affordable units are located within the downtown areas or the areas with very good accessibility to transit. As you see, there are cases in very distant areas that spend their more than a fifth of their income on transportation, which is considered very unaffordable. Denver is another case study which you can see is doing good in terms of housing affordability and transportation affordability. Almost the majority of properties in this city are considered to be affordable, spending less than 15% on transportation. The other case study is Portland, again, is considered one of affordable cities based on our analysis, while there are some few properties, again, in sprawling areas, and particularly in the Washington portion of the Portland areas, not in Oregon. But other than that, most of the properties are considered affordable in terms of transportation costs. San Francisco, again, is another example that is, you can see, again, most of the cases are affordable, while there are some very unaffordable units as well. Salt Lake City, downtown units are very affordable. When we get further, people spend more on transportation, and then in very ex-urban, far from areas far from downtown, you see more unaffordable units. Atlanta, you see the majority of units are unaffordable, spend their more than 15% on income. Dallas, the same as Atlanta, is considered an unaffordable metropolitan area according to our analysis. And Riverside is another example which is considered one of very unaffordable units. You see many examples of units that spend more than 20% of their income on transportation. Now I turn it to Reid for the conclusion.
Yeah, really quickly, so we believe this is the first attempt to look at HUD rental assistance program properties at the national scale. We think we've done as well as one can do methodologically. Research suggests that rental assistance programs, when they subsidize housing in sprawling areas, are not affordable holistically. And we think that HUD can provide more affordable units by directing subsidies to more compact, walkable, and transit-served locations. And that's it. We're ready for questions.
Okay, great. Thank you, Reid and Shima. For those viewing the webinar, please feel free to continue to submit your questions if you have them. We have about 10 minutes remaining for Q&A, and we do have a couple of questions from the audience, Reid. So the first one is, I assume parking cost availability was considered for inclusion, but was rejected. Why?
Which was considered for inclusion?
Parking cost availability, was that considered for inclusion, but was rejected?
Yeah, excuse me, I'm putting the headset back on. Yeah, well, we thought about it. We know that something like 90, I forget what the exact percentage is, but like maybe it's 98% of parking in the United States is free. You're absolutely right. If you live in a downtown and you own a car, you're going to likely pay for parking. But for the vast majority of rental assistance properties that are further from the center of the city, parking is free. So we also felt as though we were limited. You know, parking cost data. I mean, I wish I had parking cost data in all the work we do. It's really hard to come by. In fact, even coming up with the data sets we did was, as I think I mentioned, a 5-year effort. But it would have been a 15-year effort if we had to go to all of the rental assistance properties and find out if they charge for parking.
Okay, great. So this next question, I think there are 2 questions. How different are your findings with respect to LAI? In other words, have you compared LAI to your affordability indicator? So that's the first question.
Do you want to answer this? We have looked at LAI, but in a different sense. LAI gives you measures of affordability at the census block group level, as I recall. Results are in line with LAI transportation, the LAI transportation calculator, which shows a typical household in an accessible central location spends significantly less on transportation than the same household in a distant area. Mm-hmm. That has been found to be the case by others, and we found it to be the case. We also have completed a study of our sprawl measures, the ones that Shima referred to, versus housing plus transportation costs. And we have likewise found that transportation costs are much less in the less sprawling areas than they are in the more sprawling areas. Sure. Housing costs are actually higher in the more compact areas, and the sum of the two, housing plus transportation, is slightly lower in compact counties and metropolitan areas than it is in sprawling ones. So we find our results are generally in line. We have not done a comparison property by property, but it would be a good thing to do, and maybe that'll be Shima's next task.
That's great.
I should acknowledge that Shima did 100% of the number crunching, and well, she's saying no, she didn't, but she did, okay. and I'm thankful to have her as an assistant.
Great. So it seems you treat VMT and auto ownership as not jointly determined. Given you use disaggregate data, did you consider a model with endogenous vehicle stock?
Did I consider modeling exogenous?
Endogenous.
Endogenous. Vehicle ownership is endogenous. No, we didn't. Okay. I know that's a refinement. Let me explain one thing that is not obvious. We use what's called multi-level modeling, as I mentioned before. Right. And multi-level modeling, we use a program called HLM, Hierarchical Linear Modeling Software, and it doesn't do a hierarchical, it does a hierarchical model, or estimates a hierarchical model, but does not allow one to use structural equation modeling or simultaneous equation modeling. when we do simultaneous equation modeling or structural equation modeling, which treats some variables as endogenous and some as exogenous, we use a program called AMOS, which is a SPSS spinoff. And we do use structural equation modeling in a lot of our work. It does not allow one to estimate hierarchical models. Now, this isn't much of an excuse, but until recently, we haven't been able to both use hierarchical modeling and structural equation modeling with the same software package. My understanding is that M+ now allows one to do that, but that was a little beyond our ability level at the time we took this on. We're starting to. We'll be actually using estimating hierarchical structural equation models very soon in a project we're doing, but for this particular project, we did not.
Okay, so I'm going to ask these two questions. These should be a quick answer. So are the full data results of your analysis available for use by the local governments? And are the results and maps on a website?
Shima will answer this question.
So all of our modeling efforts and the equations we got from our modeling exercise will be available through, I believe, NITC, and that they are all in our final reports, which will be in the NITC website. The maps as well, we also will be available to produce more maps for local governments if any of the particular city officials are interested in to know about their city. In addition to that, we have a paper that has been submitted to the Journal of Housing Policy Debate, and it's we have a revise and resubmit decision for that. So we hope to have it published in few months, and that will be also available for publics as well as academics.
Okay. So these are kind of similar. So from which HUD housing assistant programs did your study include unit data? And does your analysis identify just the assisted properties or the numbers of units at those properties?
Yeah, it was any HUD rental assistance property, which includes Section 8. The second question was what?
Does your analysis identify just the assisted properties or the numbers of units at those properties?
No, our study does not. We simply use the property as our unit of analysis. For each property, we didn't look at the number of rental assistance units per property. We simply said, given the location of the property, it is either in an affordable or an unaffordable location when you use our models to estimate transportation cost.
Okay, great. So we have a few more questions. Why were these housing developments built where they were? Because that was where the opportunities were? To keep costs down and maximize rent affordability, developers look for less expensive land. Is it more expensive to build in compact, desirable areas? What is the suggested answer?
Yeah, well, I think the suggested answer is that HUD and its the agencies with which it coordinates should start considering transportation as well as housing costs. Right now, people pay between 30% and 40% of their income for the housing itself, and ignore, and many people do, ignore the transportation costs. But the transportation costs, we now know, and have known this very clearly since the mortgage meltdown, that transportation costs can sink a family's finances.
Mm-hmm. Right. So then is that argument
they're not built by, Yeah, they're built on a contract basis. The rental assistance properties, they're not built by HUD, but we believe that HUD could start considering transportation costs as it qualifies properties either for the program or not.
Okay, great. And
And
then
I
is it
think
not?
the answer is the cheap land. I think that was someone mentioned that, or the questioner mentioned that. I think that's probably the attraction of these remote locations. If you look at the maps we just displayed, some of the locations are very remote from jobs and amenities, and that's not necessarily the best thing for housing affordability.
Right. So this question is, it is not clear whether this study focused on transportation affordability exclusive or inclusive of housing cost. It will be good to see the research results in terms of the housing plus transportation cost as compared to total household income. So that was just a comment. And then the last question is, can I confirm that the low income household from the NHTS was determined by using the HUD rental assistance threshold of 30% of gross household income?
You can confirm that.
Okay.
Yeah, the households we looked at had incomes of 80% or less of the county median household income.
Right.
And that qualified them for HUD rental assistance. So those are the ones we looked at, and those are the ones whose transportation costs we modeled. And the person before made a terrific point. So we agree. We'd love to know if.
Hello?
Yeah, it looks like someone else has taken over. Am I right? It says How has taken over the presentation.
I can give you back the controls, Reid.
No, what I was going to say is just that we would love to know what people actually pay for the rental assistance housing. Those data are not available, or we would have added them to the transportation cost to find out if the sum of the two is more affordable. The H plus T is more affordable.
Okay.
We could have used the Center for Neighborhood Technology Location Affordability Index data, but don't have much confidence in it, and that's why we didn't simply add housing costs to our transportation cost estimate to get a total cost.
Okay, great. And I think that concludes our Q&A session. Thank you, Reid, and thank you, Shima, for a terrific presentation. It was very informative and hopefully some useful tidbits for our practitioners that are viewing the webinar. So this concludes our webinar. Thank you for joining us today, and thanks again. We are looking for your feedback so that we can continue to offer relevant webinars in the future. So please be on the lookout for an email with a short evaluation survey. As always, you can view other professional development offerings on our website, www.nitc.com. Thank you, and this concludes our webinar, and enjoy the rest of your day, folks.